Here's another type of tasks that you will be given on a quiz where you are given a function represented as a graph and you are asked to write down the expression for that function. Now the function here is q and it is a function of r because r is our independent variable. It's where we usually call this horizontal line x. So that's our independent variable. And then along y, we are marking what values q takes depending on what r is. Ultimately, what we're looking for is the expression q of r, which means q is a function of r. It's a linear function because it's a straight line. Remember, in the previous chapter, we had expressions like y equals 2 minus 5x, for example. And we called 2 our y-intercept, whereas -5 we called slope. So -5 was our slope and 2 was our y-intercept. So with functions, this right here is our y-intercept, hence we write this as a free number. It's not multiplied by our variable r. In order to complete our function, we need to figure out the slope. Remember, the slope we can figure out by making triangles, and where you make that triangle doesn't matter. I can make this little triangle and go from it, or I can take this bigger triangle. It is up to you. You can go up here and make a triangle as well, like that. Regardless of which triangle you take, the mantra, if you will, goes slope is rise over run. That's when our graphs are rising, just like in this case. As r goes to the right, as r is growing, then my function is going up, up, up. So it's a rise over run. Sometimes it's a drop over run, and we'll see another example with a drop. So in our case, it's a rise over run. I'm going to just take this triangle because it's already made and I'm lazy. So this is my rise and this is my run. Hence the slope for this particular function will be slope equals rise. It rose by 4. So rise was 4, and run was also 4. So it's 4 over 4, which is 1. So then my function is -4, which is my y-intercept, and then plus 1 times r, which is usually written as q over r equals r minus 4. We usually put positives in the front and negatives after that. If you write this as -4 plus r, no harm in that. It's up to you how you write this. Again, we had the graph by itself. First, we figured out where our y-intercept was, found it, wrote it right here as an independent number. Then we figured out the slope from this triangle. The slope was +1, and we multiplied it by the variable r. And hence we ended up with the expression for our function q of r, q as a function of r equals r minus 4 or -4 plus r. Also a rising function. Now what function is this? It's p as a function of t. So I'm looking for the expression p of t, p as a function of t equals something something plus something something times t, ultimately. So this something something will be my y-intercept. I located it's -6. So then p of t is -6. Now this something something, this x if you will be my slope. Again, you may choose any triangle you wish. I am going to go the lazy way and just take the one that's already made. It's clearly formed by the graph. The graph again is going up, so it's a rise of from -6 to 0. The rise is 6, and the run is right here, and it's from 0 to 2, so the run is 2. And then my slope is going to be 6 over 2, which is 3, which makes slope 3. So I'm just going to say plus 3 because 3 is positive, and I'm multiplying it by t. And that's my function expression. P of t is -6 plus 3t, or I can say P of t, more conventional, 3t minus 6. just like slope-intercept form for y of x equals 3x minus 6. The only difference is here we have the function that is called p, and it's function of t, not x. All right, so this function is clearly decreasing because it's going down. It's like rolling down the slope. So I can predict that my slope is going to be negative. The function is h, and that h is the function of t. So I'm looking for h of t. Y-intercept in this case is 8 right here, so it's going to be 8 plus times t. Now plus, I'm just going to keep for now, and it will turn into something else because my slope is going to be negative. So let's figure out the slope. I don't see any triangles that are already made for me. I'm going to look for specific ones. If I take this triangle right here, that is not an exact number. This is 6 something. So what you need to look for are definite points. This is a pretty definite point. So I can make a triangle like this, or I can use this triangle. So that's one option. Or I can make a triangle here. They're basically the same two triangles that are flipped. Now in this case, it's not a rise, it's a drop. And that drop is exactly 1 because I went from 8 to 7. Or if I went up here, then I went from 9 to 8. Regardless, my drop is negative 1. And then the run, if you went by this triangle, the run is from 0 to 5, which is 5. Or I could go here, that was negative 5. So it went from negative 5 to 0. The distance is still 5. So again, it doesn't matter which triangle you choose, you're going to end up with the same answer. So then my run was 5. So then my slope is negative 1/5. And you can keep it as a fraction, or you can turn that into 0.2, which is a negative. So plus negative 1/5. And then plus will be overpowered by the minus, and my final expression for my function will be h of t equals 8 minus 1/5 of t, or you could write it as a decimal if you prefer. H of t equals 8 and then minus 0.2 t. And that is your expression for the function. Now, when you're dealing with word problems, you will encounter what is called a starting point. So you see that the function doesn't go beyond this point. It doesn't exist here. Because spices sold, I cannot sell negative number of spices. So hence, it starts from 0 for the number of spices, and it's my starting point for the weekly profit. So then, what is my function? The function is weekly profit, so I can say WP, or I can just say P, or I can just say W, whichever. So I'm going to say P because it's profit. P of, and then spices sold in kilograms. Again, it's up to you what you will call it. I can say K, for example, for kilograms. Or you can say P of S for spices. Up to you. Regardless of what you call your function, you are stuck with this negative 240. So negative 240, you can think about it this way. In order to get these spices, whoever is making them obviously needs to invest some money to collect the herbs and make spices out of them, to buy packaging, to advertise, to whatever. So negative 240, you can think about it as a cost, and it's a negative number. So P of K or P of S, it's negative 240 to start with. That's our starting point. We start in the negative, invested some money, and now we're going to work towards earning back. And so as you see, as we sell spices, then the profit, first of all, we get out of debt. So we break even right here. So by the time we sell 40 kilograms of spices, we are going to earn 240 bucks, and then we are not going to be in debt anymore. Our cost will be compensated by the amount of money that we will have made. So looking at this triangle right here, I can figure out my slope. Or I can go ahead and make a triangle right here, for example. Let's say it's this. If I use this triangle, then my rise I went from 0 to 300. So my rise is 300. My run is from 40 to 90. My run is 50. So then my slope is going to be 300 divided by 50. Chip off the 0, it's 30 over 5, which is 6. Now, if I chose the triangle below this one, then my rise was from negative 240 to 0. My rise was 240. And then my run was from 0 to 40. So 40. Chip off 0, 24 over 4 is 6. So as you see, no matter which triangle I pick, the slope will be consistent. It's the same graph, the same slope. So now that is my slope, and then my variable, if you chose, if you chose k as your variable, then it's going to be 6 times k, and if you chose s as your variable for spices, that's going to be 6s. But in essence, it's the same formula. It's just whatever the variable is in your brackets, that's the variable that you're going to put right next to your slope.